Hello guys, in this video we are going to know about the how ships are going floating on the water. We know that what we know denser objects that is denser than water. The objects which are heavy density than water will sink into the water. Suppose we take like iron pieces like and also steel and something like metals we take we, if you put on water definitely it will sink, that is well known thing to everyone, yes. But ships are made up of some like aluminum, those also belongs to the metals, but they ships are not going to be uh, sink and they are floating on the water instead of sinking. But why, what is this, why this is happening, how it will happen, let's see this video. Okay, we know that water nothing but fluid. If you take a fluid have some buoyancy to it will bear some like it will oppose some force. Suppose if you take a mass of some weight you take some box of a box has weight of 100 newton. But if you put in water, the dense, I mean the weight, if you measure that weight of the box in by keeping in the water, the weight will reduce. This is due to the buoyancy force opposing, I mean moving upwards. As we see in this figure, it is opposing the weight which is coming due to the gravity. The buoyancy force is opposing and giving opposite direction force, which is reducing the total weight. If you measure that weight, it will be less than the weight which we measured in the air. But whereas in the fluid, that weight of the that box will be less. So there will be a buoyancy due to the fluid. We know, well, like we discussed in previous videos. You see my like a third, I guess third or second. In that I discussed about the buoyancy very neatly and very clearly. But here we're only discussing about the ships. But ships are also made up of metals. But why they are not sinking? Okay, let's see. You see here ships made up of some metals like aluminum, so many metals, but they are not shrinking. Why they are floating? That's the main point we are going to discuss in this video. Here we see ships are like this. They are made up of some metals, some materials which have density greater than density of these metals. Density of the ship is greater than density of this water. But even though density is greater than water, it is not shrinking. Why this is due to the force, the force buoyancy force that is exerting the water on the boat is equal to rho is the density of the fluid, and g is the acceleration due to gravity, and v is the volume displaced, and like a volume displaced, how much volume the boat the I mean water of volume of the water displaced by the boat, like or else like a volume immersed. Okay, so we want to balance the weight of the boat. Let's suppose be rho b is the density of boat, and g and volume immersed, like a volume of that one is equal to, not immersed, this is the volume of total volume of that boat. Okay, it refers to the mass mg, mass, not mass, force. It refers to the force of weight, or force, or nothing but weight of a boat. Here it is buoyancy force is balancing the weight. Okay, we know that. Okay, let me erase it. Okay, yeah, here we go. So weight of boat is balanced by the density of fluid g and the volume immersed. We know weight is mg. M can be written as rho into v, that is a density into volume. Density into volume of this is object, nothing but boat, into g into volume immersed. So even though density is greater, but boats are floating. This is due to the force balance. See, here we are making with a large surface area. We observe the bottom sides. We have large surface area. So the main thing, the all these things depends upon the volume immersed. So even though there is a difference between density. To balance that material, we need to choose. I mean, see this volume immersed or volume displaced, volume of the water displaced. So the manufacturers, the designers, and engineers look at that. They only see that the design of the boat such a way that it displaces the maximum displaces the maximum volume of the water, so that this weight of the boat can be balanced by the buoyancy force. Even though density of a boat is greater than the water, so if there is a more volume I mean displaced. Okay, now buoyancy force, let me say one more time. Buoyancy force is equal to rho gv. Here rho is the density of a fluid and g is the acceleration due to gravity, gravitational acceleration, v is the volume of the fluid displaced. So even though we can't increase the density of a material, that is a fix, that is depending upon its property. It's a material property. So what we are going to do is only displacing more volume. So we are designing the boat, not as engineers, designers designing the boat such a way that it should balance by the water, buoyancy force. Buoyancy force exerting on the boat is equal to the weight of the boat, so that boat can float on the water, so it can travel anywhere easily. So it is a wonderful thing we want to know. And thank you guys, and have a nice day. i, I hope this video gave some knowledge to you, some information which is helpful.